So conductivity is a substance's ability to conduct electricity when dissolved in water. And so we can define a substance's ability to conduct electricity into one word. It's an electrolyte. So substances that conduct electricity are called electrolytes. There are three types of these electrolytes. The first one that you guys must know is a strong electrolyte. These are substances that when they dissolve, they fully ionize. When dissolved, they fully ionize. And what this means to us is that if we were to take an example of a strong electrolyte, which once again when we use table salt, if we were to take table salt again and drop it in water, if we were to take table salt and drop it into water, it fully ionizes. That means it separates entirely into its ionic components. So remember that ionic, a side note, ionic means they are particles with charges, particles with charge. And so they can be positive and be a cation. This is positive. And anion, which is negative. And so in case here, in our example, sodium is the cation because it's positively charged, and chlorine is the anion because it's negatively charged. And so when you separate these two things in solution like this, you have the separation of positive and you have the separation of negative. And when you separate those two things, it creates an electric potential. So there's the potential for electricity to be conducted across that medium, okay? And so in this case, across water. And so when sodium and chlorine dissolve, they dissolve into their individual components, which is a positive and negative component, and that creates an electric potential which promotes the conduction of electricity. The other two examples of these that you guys must know are strong acids and strong bases. They also separate into their individual components. In the case of an acid, it would be a hydrogen ion, and in the case of a base, it would be a hydroxide ion. So strong acids and strong bases. So those are strong electrolytes. They fully ionize. Ionizing meaning they have their positive charges, they have their negative charges when they're dissolved in water. Ionic compounds, just so you guys are aware, an ionic compound has a metal and a non-metal. Ionic bond or ionic compound contains a metal and a non-metal. Contains a metal and a non-metal. So on the test or on a quiz in the future, I will make it abundantly clear that it's a metal. I'll use the common ones: iron, aluminum, those metals that you guys are very aware that they are metals, since we don't quite yet have a working knowledge of what the metals are on the periodic table, and you won't have one for tomorrow. So anyways, that's an ionic bond. Ionic bonds always form strong electrolytes, as do strong acids and bases. Weak electrolytes are the next group. Weak electrolytes. Weak electrolytes. When dissolved, they partially ionize. When dissolved, they partially ionize. Partially ionize. And so there's two examples of these that you guys must remember. It is a weak acid and a weak base, and these are the only ones. You do not need to know specific examples of a weak acid or a weak base. That's not anything we will cover in here, so don't worry about that. Just recognize that a weak acid and a weak base are weak electrolytes. And so what I mean by partially ionized is if we dropped these into solution, a common base is that is ammonia, perhaps NH3. And so when we drop this into the solution, you have the nitrogen sometimes separates from the hydrogen, and other times it stays together as NH3. And so maybe they partially ionize, maybe it's half and half. This is something that we could calculate if we were in an AP chemistry class. We're not, we're never going to do that. So just recognizing that partially ionizing means that some of them separate into positive and negative, others don't. And so that's why they are weak conductors of electricity and called weak electrolytes. The last group of electrolytes are non-electrolytes. Non-electrolytes. A non-electrolyte does not conduct electricity when dissolved. Does not conduct electricity when dissolved. And so the most common example of this is sugar when dissolved. The most common example of this is sugar. These dissolve as entire molecules. They dissolve as a molecule rather than as ions, like you guys saw up here with sodium and chlorine and down here with ammonia. They dissolve as a whole molecule. Dissolve as a whole molecule. And so what this looks like is if we took a little sugar and we dropped it into water, sugar has a molecular formula of C6H12O6. And you don't need to know this for the test, I'm just telling you. Sugar goes into water and it stays together as C6H12O6 when it's dissolved. It does not break up into carbon ions, hydrogen ions, and oxygen ions. It all stays together, okay? And so that is strong, weak, non-electrolytes. Those are the three types of solutions that will conduct electricity, or in the case of a non-electrolyte, not conduct electricity and not contribute to the conductivity of a solution. You can stop it now. Is everybody cool?
Subscribe.